Okay, so sine equals y, cosine equals x, tangent equals y over x. Cosecant is the opposite of sine, same with secant and cosine, cotangent, tangent. We're going to set y over r, x over r, y over x to cancel, to not equal 0, r over y over x, x over y not equal 0. Now here is quadrant 1, 2, 3, and 4, but also I like to look at it as cast, C-A-S-T. So quadrant 4 is C, 1, A, 2, S, 3 is T. Now what these letters represent is that each letter is a positive. So cosine is positive here. A represents all, so all three of these are positive. Sine means only sine's positive, and T means only tangent is positive. So for these three, the letters represent either sine, cosine, or tangent, but the other ones are negative. But A is all, so they're all positive. Now you set up the triangle when solving for sides as theta and the angle, and then opposite is y, sine is y. The hypotenuse is r, and that's why r is the hypotenuse. Now down here, we are given -3 and 4. So what we do is cosine is x, which is -3, and y is 4. So we know cosine has to be negative, so you go left. Positive, so opposite would be going up. So it'd be in quadrant 2. Now, what you do is label it, so -3, 4. Then you do the Pythagorean theorem to solve for C, which would be 5, because you know when you have a 3, 4, 5 triangle, it's always either going to be 5, 4, or 3. So now you do sine, cosine, and tangent of the triangle. Opposite, 4 over 5, then you get -3 over 5, and -4 over 3 for tangent. Now down here, we are given tangent equals -5 over 4. Cosine is positive because it's greater than 0. So we look at where C is positive. C is positive, positive, negative, negative. So you know it's either going to be in one of these two. Now we look at tan equals -5 over 4. So we know tan is sine over cosine. So sine would be 5, or -5 over 4. So it'd be down. So this would be 4, and this would be -5. So it would be quadrant 4. So sine is -5 over hypotenuse. To solve for hypotenuse, we do Pythagorean theorem to get 6.5. So sine is -5 over 6.5. And then secant, we know is the opposite. So it's -6.5 over 5. Now to find the reference angle, you determine where the triangle is. Let's say it's in quadrant 4. And then to find the reference angle, you start from 0, right here, and you go all the way until you hit to a hypotenuse, and then you determine that angle going around. So if we're down here, if we have a 300 degree, so it tells you to go 300 degrees, you know 360 minus 300 is 60 degrees, so theta equals 60. Now when it's given in radian, we just solve for radian, which you put it in degrees, and you get 84. Now for the third one, it's -135. So -135, and we know 180 minus 135 is 45. So theta equals 45 degrees.
So we're given our theta. So our angle is 0 degrees. So we're just on this line right here. So our sine is y. So when we're looking for y, if we're just on this line, y would equal 0. So when we're looking for cosine, we're looking for the x. So then we move 1 over for the x. And then for 90 degrees, we're right here. This is our start point. Go up 90 degrees. So we're up here. So when we're looking for our y, we're going 1 up for y, and then we're not going anywhere for the x, so that's 0 when we're looking for the cosine. And then 180, So if we start right here, and then we go over to over here, we're just looking for our y, and just like over here, our y, we aren't going anywhere up or down, so it would equal 0. And then our cosine, if we started right here, going over 1, would be left, so -1 for our x. And then 270, we're going down here, because this is 360, you go down to 270 right here. So then if you're looking for your y, you're going down 1, so that'd be -1. And then for your x, you're not going right or left, so that would equal 0. Okay, so you're looking for tan, -210. So you're starting at 0, you're going -210. There's -180, and -30 again. So then you have this triangle right here, and since we have this, we know that our theta would be 30. So since the angle is 30, we know we have the type of triangle with these sides, a 60-90 triangle. So then when we figure that out, we can use tan to figure out that the answer would be -3/3. And then over here we're putting radians, so we have to convert this to degrees. So we cancel out the pi's, and we do 180 over pi. And we cancel out the pi's, so it'll be 11 times 180 divided by 4. So we get 495 degrees. So we start right here, go around 360, you gotta go up to 495 right here. And then since we're at a 45-degree angle, we know that we have an equilateral triangle. So we find out our sides by these two being equal, and then our hypotenuse is square root of 2. And then as we move down here, so as we let the sine equal 1/3, we look over in quadrant 2. So we're in quadrant 2, we make our triangle. Sine, opposite, over hypotenuse. So we set our theta opposite, 1 over hypotenuse, 3. And then by the Pythagorean theorem, we can figure out this angle would equal -square root of 8. So then we find out the rest of the cosine, tangent, secant, cosecant, and cotangent by using the rest of our functions. And then so we get -square root 8 over 3, -8, -square root 8 over 8. And then we just switch these for secant, cosecant, and cotangent. Alright, so with these, you know the cosecant is positive. So then by that you figure out that which quadrant you will be in. And then since we're looking for the reference angle, you will start here and you will go to each hypotenuse. So you start here, you go to this hypotenuse, which is 45, and then you have to go all the way around to get this one, which is 315 degrees. So then you know your cotangent is negative. So then with that you can find out which quadrant to start in. And then as we start here again, we go to each hypotenuse. We find here is 150 degrees. And then we start here again, go around to hypotenuse. And then we find this is 330 degrees. And then lastly, with this one, we know that the sine is -1/2. So we start in we know which quadrant to start in. So then we always start right here at 0 degrees, and then we go to each hypotenuse. So we're going around to 180, then a little bit more to 210. So that's one answer. And then we go around one more time, all the way to this hypotenuse, which would equal 330 degrees.